All right, and best way I can say this one is just rational expressions, day 2. Again, keeping up with notes, this is number 16. Today is Monday, 4/26. All right, and again, this is just really an extension of what we were doing Friday. Friday, we went back and just reminded you of some factoring things. Today is going to be basically the same thing. We're going to remind you of some more factoring things, and just kind of have you go through some parts on this one. And all we're going to do for this one is we're going to simplify and state the excluded values. Okay, and all we're doing is just taking the exact same thing we did Friday. We're just now the difference is for most of what we're going to do today is that for the problems that we have, it's not going to be just a um, not just one single expression like we were doing on Friday. This one, you're going to have one expression, one rational expression times another rational expression. So it looks something like that. Okay. But it's still the same thing we were doing on Friday. The simplifying part means you have to factor and cancel. The state the excluded part, that's still your denominator equal to 0. So still the same thing. Now, again, it's just we're stretching this out. We've got to do a little bit more work to kind of get through all the parts that go through this one. Okay. And as long as it's x squared, the factoring gets a little bit easier because if it starts off with x squared, it's got to be x times x. For this one, we're doing the factors of negative 10 that equal 3. And again, most of the time, the factors, there's not that big a list of them. With 10, it's either 1 times 10, which is not going to get us to 3, which means it has to be 5 and 2. And since the b term is positive, we know the 5 is going to have to be positive. And if you do a negative 10 divided by a positive 5, that's going to make that a negative or minus 2. Okay. For this numerator, it's 5x plus 40. It's not an x squared term, so the only thing you can look for on this one is a greatest common factor. In that case, you can divide both numbers by 5. So we'll take the 5 out of this one, leaves you with x. If you take 40 and divide it by 5, that would be an 8. All right, this denominator with the 4, nothing you can do with it, so it just stays there. And for this one, we're also going to do the same factoring here because we start with x squared. So we're looking for the factors of 16 that would get us to 6. And again, there's not that many options. It's not going to be 1 times 16. It's not going to be 4 times 4. For this one, it's got to be 2 times 8. Again, the b term is positive, so the bigger number has to be positive. So that means it's going to be an x plus 8. And if you do negative 16 divided by positive 8, that's going to make that a negative 2. Okay, so we've factored everything as much as you possibly can. Now you're just going to cancel. We're going to get rid of the x minus 2s. Going to get rid of the x plus 8s. And remember, when you're canceling, you have to cancel top to bottom. Sometimes people will try to cancel side to side, but remember, you've got to have an x plus 8 on the top and one on the bottom to go through and cancel everything. And once you've canceled everything that's the same, just bring it all together. So now we've got 5 times x plus 5 over 4. And you do not have to do distributed property here. Just leave it just like that, and then we're good to go. Okay. As far as excluded values go, this is where they'll give you the x not equal to, and then they'll just give you a big box at the end and tell you to go back and plug in the numbers for this one. That's where you take every single denominator that you have that's factored out and set all those equal to 0. Now, the one thing you don't have to do is if you have a number, you don't have to worry about it because if you set 4 equal to 0, that doesn't make any sense anyway. So, that's that. We don't have to worry about that. Now, if it was x, that would be different. If it was x equals 0, then yeah, you could do that because then that would make x equal 0. But if it's just 4 equals 0, that doesn't make any sense. There's really not much you can do there. All right, so for this one, we're going to add 2 to both sides, and then we're going to subtract 8 on this one. So in that case, we're going to have 2 excluded values, one at positive 2 and one at negative 8. Okay, so everything we're doing today, still factoring, still canceling, still going through and setting everything up. To kind of get through the parts on these. All right, now here's one other thing, and I thought about doing this, but it just kind of, it's the same factoring, but just slows things down. So you don't write this down, just kind of watch. But let's just say that we were working through a problem. Again, you don't have to write this down if you just want to kind of watch through it. What if we got to a problem and we had, let's say we had x minus 5, x minus 6, x plus 5, x minus 5 times x plus 1, x plus 5, x plus 1, and x minus 6. Again, don't worry about writing this one down. Just kind of watch because this is just a what if question. All right, we start to cancel. There's x minus 5s. Those are gone. There's x plus 1s. Those are gone. There's an x plus 5 and an x plus 5 there, and an x minus 6 and an x minus 6 there. So what happens if everything cancels out? What's our answer going to be? Anybody remember? Y'all remember going back, let's say, if we had 8 over 8, we'd cancel both of these and put 1s in its places. Remember when you cancel these, technically you're still putting 1s when you cancel these two. You put a 1 when you cancel this one. You put a 1 when you cancel this one. You put a 1 when you cancel that one. So if it happens that if everything cancels out, the answer would be just 1. Now, I don't know that that's going to happen, but just to be on the safe side, because sometimes I get a little bit sneaky on people. If everything canceled out and there's nothing else left over, technically the answer would just be a 1 in that case. I don't know that will happen, but just to be on the safe side of something like that possibly happening, if everything cancels, just put a 1 because everything cancels out. Because basically it's like this one, it's the same thing over itself. If you have the same thing over itself, then that just makes it 1. Okay, so anyway, don't know that will happen, but just to be on the safe side, we'll throw that one out there. All right, so for this one, give you one big one here that's got a lot of factoring with it. Let's go 3x squared plus 19x plus 20. And that's over 9x squared minus 16 times 3x squared plus 8x minus 16 over x squared plus x minus 20. Okay, biggest reason was I want to go back and show you this one because there's a bunch of different things, but this has got some different things in it to make sure that everybody remembers to do factoring wise what's going on here. All right, starting with the numerator on the left up here, we've got 3x squared plus 19x plus 20. So for that one, we've got to do the AC method. So we're going to start off with 3 times 20. The good news is all the numbers are positive, so it's a positive 60 that we're looking for the factors of. And the sum is going to equal positive 19. All right, if you go through your numbers, it's not 1 and 60. It's not 2 and 30. It's not 3 and 10. 4 and 15 would be the one we're looking for. And again, there's only one more set of numbers. That would be the 6 and the 10. But since they're all positive, that makes this one a little bit easier to work with because we're just looking for the numbers that's going to add up to be 19, and that'll be in the 4 and the 5. All right, I think we mentioned one like this on Friday. I think we did one. that if you're doing the AC method, if you multiply by 3 in the beginning, you've got to go back and divide both numbers by 3 to make this thing even its way back out. That one won't simplify, so this is where we get to do bottoms up to make it 3x plus 4. That one does simplify, so we get to make that one x plus 5. Okay, and we're going to come back to this denominator here in just a second. I'm going to go ahead and work with this numerator since it's basically the same thing, just a different set of numbers. This one, same type setup. We've got to do 3 times negative 16, which would be negative 48. So we got to look for the factors of negative 48 where the sum is going to equal positive 8. All right, this one a little bit tougher because anytime you've got a negative in there, that's going to make things a little bit more complicated because then we got to worry about what all the signs are. Okay, 48's got a decent amount of possible factors we could get through this one. So we got 1 and 48, 2 and 24, 3, 16, 4, 12, and 6 and 8. Okay, B term is positive, so we know the bigger number has to be positive. To get the sign of the other number, a negative divided by positive is a negative, so the smaller number is going to be a negative, and the bigger number is going to be a positive. Which means we've got to subtract the numbers to get 8. Well, that's going to be the 4 and the 12. Okay, but the same setup on this one is that once we've got these factors, because we multiplied by 3 in the beginning, if you look at the last numbers, we've got 4 times 12, that gives us 48. These numbers are too big, so we're going to go back through and divide by 3 because we multiplied by 3. This one we'll do bottoms up, make it 3x minus 4. That one will simplify and just make it x plus 4. Okay, and those just it adds that degree of difficulty because now you've got that extra step that you've got to go through the AC method to get there. So anytime that first number is something other than just x squared, it's now there's a chance it could be just a greatest common factor, but more than likely you're going to have to do the AC method on those to get those. All right. Now what I'm going to do is I'm going to just rewrite these answers that's here. So that would be 3x plus 4 and x plus 5 for this numerator. This numerator was 3x minus 4 and x plus 4. Okay, and then I'm just going to cover up all that work that we did. So these were our two numerators that got us here. Now we're going to worry about just factoring out these two denominators. All right, for the first denominator, hopefully that one you kind of, again, it's two terms, and if you've got your blue sheet out, if you're not having it out, you might want to do that because that would be helpful here. If you have two terms, there's only two options. Either there's a greatest common factor, which with 9 and 16, there's not one. If not, then it's a difference of two perfect squares. 9 is 3 times 3. So we'll make that 3x and 3x. 16 is 4 times 4. And since the 16 is negative, one's got to be positive and one's got to be negative. So that was the difference of two perfect squares, which was that shortcut. Take the square root of this number, which goes here and here. Take the square root of 16, which will be the second number that goes there and there. All right, and finally on this one, the last one. Now this one's a shortcut because it starts off with x squared, which means this has to be x times x. Now we're just looking for the factors of negative 20, where the sum is going to equal positive 1. And if you do factors of 20, well, it's not going to be 1 and 20. It's not going to be 2 and 10. It's got to be 4 and 5. And the B term is positive, so the bigger number has to be positive. And if we do negative 20 divided by positive 5, that means the 4 would have to be in there. Okay, so that one takes a little while to get through all the factoring. But now we get to cancel. So we've got a 3x plus 4 here and here. We've got a 3x minus 4 there and there. And we've got an x plus 5 and an x plus 5 there. So finally at the end, we get down to x plus 4 over x minus 4. All right, and then for excluded values, that's where they give you the x not equal to, and then they just give you a box, and you got to go back and fill in the numbers. We've got to take every single original denominator we had that we factored back here before we did the canceling, and we've got to set all those equal to 0. So the x minus 4 and the equal to 0 and the x plus 5 equal to 0, those two are not bad at all. Because this one will just add 4, this one will just subtract 5. All right, then we also got to do the same thing with the 3x plus 4 and the 3x minus 4. Okay, so there's where you take every single denominator you have, you got to set equal to 0. These take just a little bit longer because now you've got to subtract 4 from both sides. And then you've got to divide by 3. So that makes that negative 4/3. And the good news with this one is it's the same answer, but now we'll just change that one sign. So where this was negative 4/3, this one's going to be positive 4/3. Okay, so a lot of work. It hit a little bit of everything. We had to do the AC method. You had regular factoring. You had to do the difference of perfect squares. So this is one of those problems where it's probably almost a worst case scenario because we ran across almost every single thing we had to do. The good thing, if there's any good news, is you won't see any that will be factored by grouping because everything they do, they either make it 2 or 3 terms just to make things a little bit more simple when they're going through these. All right, so all that's multiplication. Now, here's one that it's should have done this one on Friday, but again, we're just kind of intro on some stuff, so we're going to throw this one in here. It's multiplication, but it's not really multiplication. So this is just a different version one. It's actually a little bit shorter. Because I always like to show you this one because sometimes this is one that kind of sneak up on people. All right, so let's say you've got 24x to the third y squared, and that's over negative 6x squared and y to the fifth. Okay, and the big difference that hopefully you'll kind of see on this one, there's a couple of differences, but this one is just everything's all kind of crammed together. This one, you got the pluses and the minuses, and everything's kind of spaced out for one like this. So this one, you got to take a little bit of a different approach, and it's actually an easier approach on this one. That when you have one where everything is just all multiplied together in one big blob, what you're going to do is you're going to break this thing apart by letters. So break it apart by the numbers that you have in front, and then you break it apart by the letters that's at the back end of it. So it's almost like 3 different problems on this one. We're going to start off with 24 over negative 6, just working with the numbers. And then go to the next letter. You've got x to the third over x squared. And then you go y squared over y to the fifth. Okay, and then you just work the problem from there one piece at a time. If you had to, and this would be like, back in 3rd or 4th grade or 5th grade. If you had to simplify 24 over negative 6, you would divide them both by negative 6, and you'd get negative 4 over 1. Right, and if you remember, if you're simplifying powers of exponents, this is where you just subtract. 3 minus 2 is 1. The bigger number was on top, so you're going to have 1x left on the top. And we do the y's here, same thing, go subtract 5 minus 2. The bigger exponents is on the bottom, so when you subtract 5 and 2, you're going to have 3 that's going to be left on the bottom. Okay, now, and if it's over 1 like this one is, if you do negative 4 divided by 1, that doesn't really do a whole lot. So you can make this just negative 4x over y to the third. And the good news on this one is where you put the y doesn't matter. That would be a correct answer. You can also put 4x over negative y to the third would be a correct answer. Or you could just put the negative right in the middle and do 4x over y to the third like that. So whether you do this one or this one or this one, it doesn't matter where you put the negative. As long as you've got a negative somewhere, whether it's in the top or the bottom or the middle, and as long as you've got a 4x on the top and y to the third on the bottom, where you put the negative, it doesn't really matter where you put it there. All right, and if you do run across a problem like this one, the good news is that they usually will kind of give you boxes here. They'll give you a box for the x, and then they give you a box for the y, because now you've got two variables. Before we just always had x's. This time, if you've got extra variables, they'll give you a box for every variable, because now basically they're saying, all right, now it could be that you could set this part of the denominator equal to 0, which means in that case you're just going to put x equal to 0. And same thing for the y, because once you set y equal to 0, it doesn't matter if it's y to the fifth or not. If you do y to the fifth equals 0, that just means you're doing 0 times 0 times 0 times 0 times 0, which is still just going to be 0. Okay, so where you have those, again, just one number at a time, one piece of it at a time, and just take it one small little piece at a time to put it all back together. Let me show you one more of those real quick, because those are really short when it comes off of it. And then we've got one other big thing we got to do, and then one other little thing that kind of goes with it. Again, this one won't be real long. It'll be a short one. All right, so let's go with 12x to the fifth y over 18x squared y to the 14th. All right, again, just one piece at a time. We're going to do 12 over 18. We're going to do x to the fifth over x squared, and then we're going to do y over y to the 14th. All right, with 12 over 18, you can divide them by 2, you can divide them by 3, but if you take out the biggest number, in this case, you can divide them both by 6. So it's going to make that 2 over 3. All right, with the x's, subtract 5 and 2, that's going to be 3. Since the bigger power is on top, you put the bigger number on top. Put the leftovers on top. And the only thing you have to do with the y's is just remember that y by itself, there's technically 1 there. So you're going to do 14 minus 1, which is 13. Bigger exponents on the bottom, so your leftovers have to go on the bottom, so it'll be y 13th on the bottom. Okay, and same thing with these. The good news is that every time you do a problem like this, you're just taking whatever variable you have in the denominator and you just set those equal to 0. If there was a z on the bottom, then you'd go back and tell me that z equals 0. So you have to exclude that one. So it's always pretty easy on those because it's just each number equal to 0. Okay. One other kind of big thing, and then one other little small thing, and then we'll wrap this up. For division, division is really not any different than multiplication, because we're going to do like we've done with every other division problem with a lot of the ones we've done so far. Is first thing is you're just going to rewrite it as a multiplication problem. And remember to do that. That's where we're just going to do keep it, change it, flip it. And every time I do that, I always want to go get some chicken after we talk about this. So just rewrite it as a multiplication problem, and then you factor and cancel, just like we're doing with a regular multiplication problem. Okay, so it's really not any different. And the problems we picked on this one, the only thing that would be different is that with these problems, anything that ever winds up in the denominator, whether it's the original problem here or whether it's the problem we've got rewritten as a multiplication problem, you'd have to set every single little thing equal to 0 for excluded values. But I picked problems that they're not going to ask for excluded values on these, so you're just going to have to just work them out, and go from there. So, all right, we're only going to do one of these because once you've seen one, that's really all you need, because it's really straightforward. Okay, so we're going to keep it, change it, and then we're going to flip it. And it's one of those problems, if you're doing one of these online, if you're looking at it, you don't even have to write this. You can just go ahead in your head and think, all right, I'm going to keep it, change it, flip it. So then we'll make it 6 there. And then we'll go there. And then just start factoring out what you can do. There's nothing you can do to factor x minus 2. Nothing you can do with a 4. Right now, there's nothing you can do with a 6. So for this one, we're looking for the factors of 10. That would get us to 3. Well, it's not going to be 1 and 10, so it's got to be 2 and 5. And this one, it's all about the signs. The b term is positive. So that means, again, the bigger number has to be positive. And if we divide a negative 10 and a positive 5, that means the 2's got to be negative. All right, so everything's factored as much as you can. Now you can cancel out the x minus 2's. The one other small thing you can do that will sometimes sneak up on people is that if this is your answer, remember that if that x plus 5 wasn't here, if it was just 6 over 4, you could divide both of those by 2. So you've got to go ahead and do that same thing here. Go ahead and divide both of these numbers by 2. And make that 3 over 2 times x plus 5. And again, with division problems, I'm not going to have you worry about doing excluded values, because you do enough of that with the multiplication problems. That's once you get there, that's all you're going to have to do. You're not going to have to do any excluded values on the divisions, or just the multiplications with those. All right. Now, one last thing that you have to do. This is something it's a big care. It's not going to happen, but maybe it might happen once on the homework. It might happen once on the test. It might not happen at all on either one. It may just happen one time in one of them. But anyway, this is something, it's not, you just have to be careful with these. And I can remember doing this. This hit me when I was in high school, and I remember I did not like this at all, because I thought it was kind of, I don't want to say it was cheap, but it was tricky. All right, let's say you've got a problem with this one. We've already got it factored. We've got to go back and do the simplifying canceling. If you stick to the rules we've talked about so far, that you've got to have the same thing in the numerator and denominator cancel stuff on this one. Do we have anything that's the same? We don't, do we? I mean, it's, and you're like, well, that's close, because this one's x minus 2 and that one's 2 minus x. And that's the part that gets tricky on this one. So here's where you have to be careful. With the x minus 2 and the 2 minus x, we have the correct numbers and variables. Because they both got an X, they both got a 2. So the numbers and the variables, all that stuff is correct, but the signs are wrong. We'll just say the signs are reversed because this one has a positive 2, this one's got a negative 2, this one's got a negative X, that one's got a positive X. And here's the trick on this one is that if you do that, they're there. It's just one of them's not written the correct way. Um, we'll just say to fix this, we're going to divide a negative 1 . So the way we're going to fix this is we're basically going to take, like, it's almost like we're taking out the greatest common factor of negative 1. And by doing that, it's actually going to make this thing work out here. So what we're going to do now, most of the time, you can do it with the X minus 2 or you can do it with the 2 minus X. We usually like having the X first. So what we're going to do is we're going to take this 2 minus X that we have here and we're going to factor out a negative 1. Which if we do that, that'll make that a negative 2. If you take negative X and divide it by a negative 1, that's going to make that a positive X. All right, and then we're just going to rewrite it so we can see how it would normally look. That we're going to just reverse these two around. We're going to put the X first and then the minus 2 second. Okay, and by doing that one now, if we take this original problem we had up here, if we take out the 2 minus X that we had here, and we're going to take that and replace it with this. So now we've got negative 1 times X minus 2 over 4 times 1 over X plus 5 and X minus 2. So we're taking out the 2 minus X and we're basically just rewriting it as negative 1 times X minus 2. Again, it's just taking out the negative 1. That reverses everything. That now you can put the X first and now you can put the 2 second and kind of go with it that route. Now you've got stuff you can actually cancel because now we can cancel the X minus 2's and that's going to leave us with negative 1 over 4 times X plus 5. Okay, again, that won't happen often. Maybe one time in the homework, maybe one time on a test question, but that's there just to be on the safe side in case something like that pops up.